Hello, my name is Andrew Walker, and I will be giving you a brief summary of the FloDar system. The FloDar system is made to collect and store data on the flow rate, turbidity, and temperature of water as it flows through a pipe section. This data will be used to find the relationship between water flowing through collection tiles and the landslide events within an area, but may be used in any application where parameters of liquid flow through pipe systems are of interest. Here we can see our systems diagram. It is comprised of three main sections. 1. The PVC piping, in which the water will flow. 2. The pelican case, which holds all of the electrical components of the system. And 3. The solar charging system, to increase the longevity of the system in the field. This is the top of the inside of the pelican case, which holds our battery for the system. The battery is able to supply the ultrasonic flow meter with a necessary 12 volts and the microcomputing group, which needs 5 volts. It is charged using a 25-watt solar panel and a 10-amp controller. This is the bottom of the pelican case, which holds the ultrasonic flow meter on the left and the microcomputing group on the right. The transducer connections enter in from the left into the ultrasonic flow meter controller, and the turbidity and the thermocouple connections enter in from the right. The microcomputing group contains a Feather M0, an Opens Hypnos board, and a specialized PCB created to hold all sensor components and convert signals to the proper voltage when necessary. This is the circuit diagram for our project. It shows the 0 amp to 20 amp current signal to 0 volts to 3 volts signal conversion necessary for the ultrasonic flow meter, and the voltage divide necessary to convert the 5 volts of the DF robot turbidity sensor to 3 volts. Both signal conversions allow for the implementation of the ADS1115 for higher precision. The bottom left shows the Hypnos board, which supplies all the proper voltage for the components within the system. It is also responsible for the timing intervals used by the researcher and the data recording to SD. This is the PVC pipe that contains the turbidity sensor and the thermocouple. It is separate from the section of pipe containing the transducers to allow for maintenance and repair for these integrated components when it might be necessary. Lastly, this is an example of the implemented transducers. This example does not contain the transducer holder created by Dexter Carpenter, who has just recently joined the project. As seen in the bottom left, this will allow for an easier, more secure installation while allowing for adjustable spacing if there is any variation between PVC pipes. Thank you for listening, and I hope you've learned a little bit about the FloDar project.